Hey, Algebra 2 class, we're going to go over our guided practice problems for lesson 8.4c. In this lesson, we're going to practice graphing equations of parabolas, circles, and ellipses. So we're going to start the sorting out process, looking at our equations and deciding what kind of equation they are. Do they represent a parabola, circle, or ellipse? And then once we've decided which kind of equation it is, to pull out the necessary information from that equation to be able to graph those parabolas, circles, or ellipses. It will be one of those three shapes for each of these problems. All right, so for guided practice A, we are presented with the equation y squared plus 16x is equal to 0. And so what we're going to do first of all is think, well, what is it going to be? Is it going to be a parabola, a circle, or an ellipse? We see y squared and we see x, not x squared. We see y squared and just x. Anytime one of the variables is squared and the other one is just a variable to the first power, we're going to know we're working with a parabola. To graph this parabola, we're going to need to know which way it opens and what the focus and directrix are. So first thing we're going to do is we're going to get this into standard form. We're going to subtract 16x from both sides and see in standard form that we have a parabola y squared equals negative 16x. And recall that parabolas that are the y squared type will open either left or right. If this were an x squared and this were a y, then we would know that it opens up or down. Then we have the y squared type here. So the next step is to figure out what our focus and our directrix are. So the general form for our parabolas that open left or right are y squared is equal to 4px. So we're going to replace this coefficient, this negative 16 here, with that 4p, so we can solve for p and find out what our focus is, and from that what our directrix is. 4p is equal to negative 16 then. Dividing both sides by 4, p is negative 4. So our focus is at negative 4, 0. We know it's at negative 4, 0, not 0, negative 4, because we know our parabola opens either left or right. And once we put down the negative 4, we're going to see that we're on the left-hand side of the origin, and we're going to be keeping that focus inside of our parabola here. So negative 4, 0 means that the parabola will open so that the focus is inside. We're not going to be too concerned with how fat or how skinny that parabola is. We're just going to open a general parabola on the origin that encompasses this focus inside. Our directrix, of course, will be this vertical line that is the opposite of where that vertex is on the parabola. Remember that our vertical lines are described by an equation x equals a number, and that number 4 is going to be the opposite of our focus number. We always see that in our parabolas. The focus numbers and the directrix number for the equation is always opposite. So here we have the graph then completed. We have the parabola drawn. Because it's a parabola, we will also include the directrix in our graph, and we'll label it directrix x equals 4. We have our focus labeled here, negative 4, 0, and we have our parabola opening to the left. Next problem, let's see, we're looking at 3x squared plus 3y squared equals 15. This time we have both x squareds and y squareds added together, and we know that both in a circle and an ellipse, that would be the case, that we have something along the line of an x squared and a y squared added together. So the question is, which one is it? Well, circles are actually special kinds of ellipses. Circles are ellipses that happen to have exactly the same coefficient on the x squared and the y squared. So since we now know this is a circle because these coefficients are the same on our x squared and our y squared, we want to get into standard form for a circle. And our circle equation standard form is x squared plus y squared is equal to r squared. So what we're going to do is we're going to divide the entire equation by 3 on both sides so that we can get into that standard form. And that gives us x squared plus y squared is equal to 5. There's our circle equation. All right, so now that we have our equation in standard form, we can set about finding out what the radius is so that we can figure out how to graph this equation of our circle centered at the origin. So our r squared will be 5, because remember r squared is what the x squared and the y squared added together equal to. So r squared is 5. When we take the square root of 5, then we find it's approximately 2.2. So now I can place 4 points on the axes, because they're convenient locations to place those points to determine our radius. 2.2 to the right, 2.2 up, 2.2 to the left, 2.2 down, and then we'll draw as round a circle as we can through those 4 points. And we're done with guided practice B. Guided practice C, we can probably guess, since we've graphed a parabola already and we've already graphed a circle, you're going to probably guess our last guided practice problem will be an ellipse, and you're right. 100x squared plus 16y squared equals 1600. It is an ellipse. Again, we're going to notice the x squared plus y squared terms that we have. And we're going to notice the different coefficients on those x squared and y squared terms, which means it's not a circle. It's not a parabola because parabolas have only one y squared or one x squared. And this has both x squared and y squared. So it is an ellipse with these different coefficients. And so our job is to write this equation now in standard form for an ellipse. Remember, for an ellipse, we're going to need to be equal to 1. And this is not the number 1. So to turn this into the number 1, we're going to take 1600 and divide it by 1600 so that we can end up in standard form for an ellipse. And here is what I'm going to be doing to get down to that 1. 1600 divided by 1600 is 1. So I'm also dividing these by 1600 to keep the equation true. And so 100 goes into 1600 16 times. So we cancel the 100 and divide 1600 by 100, and that gives us 16 here. And over here, we divide both the numerator and the denominator by 16. 16 divided by 16 is 1, which is hiding here in front of the y squared. And 1600 divided by 16 is 100. So here we are in standard form for our ellipse. Now all we have to do is pull off our a and our b values so that we can actually graph the ellipse, so that we can get our vertex and our covertex. So we're going to notice first of all that this will be an ellipse with a major vertical axis because 100 is greater than 16. So that means this is our a squared term and this is our b squared term. So a squared being 100, because this is larger than 16, a squared is 100. That means when we take the square root, a is 10. B squared then would be underneath our x squared, so b squared is 16. I guess this b is 4 when we take the square root of 16. And then all we have to do is graph those points. Now remember that our a squared term is going to be on the vertical axis. So that means that we're going to have to put the 10 above the origin and 10 below. We're not going to put 10 to the right or left because it pairs with this y squared term. That means we're on the vertical axis for our a number. So up 10, down 10. And then for our minor axis, we have our b squared turning out to be 4 from our 16. Square root of 16 is 4. So we'll go 4 to the right and 4 to the left of the origin, and we'll plot those points. And then we draw as careful an ellipses as we can through those 4 points, knowing that we are not all artists. It won't be probably a perfect looking ellipse, but it'll be close enough. So kind of a quasi football shape with these rounded corners there. All right, so you have an example for each of the different types of graphs you'll be drawing. So for this lesson, first determine what will the shape of the graph be, circle, ellipse, or parabola. Once you've decided what shape it is, rewrite that equation if necessary in standard form. Then once we're in standard form, pull out the necessary information needed to graph the equation, and then go ahead and graph it. All right, and we'll see you next time.